Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. In the lecture series of Material Studio, we are at lecture number 40, and in today's lecture, we will learn about how to calculate electron density and CASTEP, and Material Studio. So today we will continue our journey into material science with electron density. Since in our last lecture we learned how to calculate STM images, scanning tunneling microscopy, and which let us speak at the surface of material. And now we are going even deeper to map electron density, which is closely connected to what we saw in STM. Basically, electron density tells us where electrons are in a material, helping us understand how material behave, bond, and react. Electrons are the key to how material work. By studying electron density, we can see how material respond to different atoms and how we can improve them for electronic energy storage and catalyst. So in this lecture, I will show you how to calculate electron density using CASTEP and Material Studio. And by the end, you will know how to set up the calculation, see the electron cloud in 3D, and analyze your results like professional researcher. So we will look at some practical example like Ti2C and see how adding other atom called dopant change the electron distribution. So think of electron as the cloud surrounding atoms, and electron density shows how thick or concentrated this cloud is in different areas. Areas with many electrons are usually where bonds from are where the material can react. Area with fewer electrons are empty space between atoms. Simply put, electron density is a map of where electron and the material. This helps us understand material even before experiment, saving time and effort. So before towards moving toward the calculation steps, it's important that the structure is fully optimized. So the structure for which you want to calculate electron density should be fully optimized. This means that atoms are in their correct position. So you saw I already optimized the structure, and which atoms are in their correct position and relaxed. If atoms are not relaxed, the results won't be accurate. So make sure your structure represent the material you want to study. If you are working with top material, the extra atom should be placed correctly. Also, electron density file can be a large, so make sure you have enough disk space. And now let's start the calculation step. Since this is my optimized structure, uh, for the density electron density calculation, open the case step tab. So also keep in mind that no atom over here should be do not overlap anywhere in the entire structure. So since I applied the CPK mode, so that's why the structure we have like this. Anyhow, I already confirmed that my optimization is fine. And open the calculation step. So from the task section, select the energy. Since we already calculate the geometry optimization, we already we already optimize our structure. So from the task section, you must select energy because we only want to calculate electron density, not change the structure. And then next go toward the property section. From here we have options. Yes, electron density difference, and also I want to calculate the electron localization function. Also I want to check the orbitals. Leave all the steps as it is, as since you use for optimization. No need to change anything else. go with the same perimeter and then run the calculation. And once the calculation has been completed, like I already performed calculation, so okay, so let me delete first and then we will try to analyze. Okay, so since I already analyzed the structure, I want to make analysis again in front of you. Let me first okay, so this is my structure. Okay, this is my structure and I calculate electron density difference. Now it's time to analyze how to analyze electron density. Since I already performed the analysis process, so firstly I delete, I will perform in front of you people again. For this, open the calculate CASTEP tab and then click on analysis. Here we have options of electron density. So you see I already performed since electron density option and then click on save to density file. So then system will save your density file. So keep in mind you must select the view isosurface option on the while in analysis process. Okay, after that simply click on import. Yes, since I already generate the file, so I just want to take my permission. Okay, this is electron density, but um, it's not good. Let's visualize. So after that we have option of color map. Open the color map tab. Okay, before moving ahead, let's set the display style to volume. Okay, so from the atom select none. Okay, and in the lattice it should be none, and in the field it should be visible. Not dot style, volume style is good, and I want to apply the highest quality. Okay, apply the isosurfaces, electron density. Yes, with ISO value 0.2. Keep in mind the this image strongly depend on ISO values. So while selecting the ISO values, so you have to take care about. Okay, so this is how you calculate the electron density. Let's conclude the lecture. So today we learn how to calculate and visualize electron density using CASTEP. So we saw that electron density shows where electrons are in material and gives insight into bonding and reactivity. We learn how to prepare the structure, set up the calculation, visualize the results, and analyze electron density of pure and dark like we just do calculation for dark material. The same process you can repeat for your pure structure. Okay, so and this lecture built on our previous STM lessons, showing a deeper understanding of the electron we saw in STM images. uh, Thank you for joining the lecture and Material Studio Zone. If you found it helpful, please like the video and subscribe for more tutorials. Also, if you have a question,